Alright, so welcome to my Sprint 7 GitHub and Team Gantt video. I'm going to be showing you the different commit calls that I made throughout this sprint. So first I'm going to go to my first one called the added web scrape API call. We're trying to add web scrape, me and Aaron was trying to add web scrape throughout this sprint to see what we can get. That's going to be the hardest part of our app because in order for our app to work properly, we need price data. But the way web scraping works for React Native is kind of hard to do that. So I was trying to implement different ways of going about this. There was something called React Native Cheerio, which is a package that you can download from React Native. And using Cheerio is a way to parse HTML data. So this just was a test. They call it Vaughn's API, but I used a sample API. Well, not really API, but a query search in Amazon to search for a specific item such as graphic card, which you see is passing right here, and then I'll wait for that fetch to get that call, and then I get the HTML by doing the response.text. So this Cheerio.load loads this HTML string and parses it, and it puts all the white space together. So what makes Cheerio so hard is actually parsing the data. The way to parse the data is, as you can see here, I had to call a tag name, which is span in this case, and get the class name, where the class is equal to a offscreen, which is what they had in the HTML. And then for each class offscreen is how I would extract the prices for each graphics card. So in this class offscreen, when I do this .each function, it will grab each price from each graphics card based on this class and then join it together into an array. Now the problem with this is that the HTML would differ from website to website. So this class offscreen wouldn't work properly because that's only working for this particular API key, but this wouldn't be working from API call to API call. So it'd be a lot of hard coding trying to figure out the different class names and what tags were needed to actually get the pricing data. So this is just a test to see. It did work, but it would take a lot of work to actually get it working. And also, so I'm gonna go back to another commit, web scrape changes. This is trying to use Amazon Prime, but still the same case. So decided to go a different way, where in this case, with the help of Aaron, we've used a specific API call. We're able to find this API call within the network and the developer tools. So in this case, we use Vaughn's. In the network tools, they had a request for price, a price request. There was an actual request which displayed the item name and description and everything, but we needed a subscription key to access that information. But there was a network request right under there, which is only retrieves the price, which is what we wanted. So we were able to retrieve this price for the example milk. So we fetched that milk price, used it and turned it into a JSON object, and then extracted the milk price. It was under the product info and then price. And when we would do a console log, we would actually print out the price of that milk. So this will help out a lot. So now, I continue to go up and see what we actually used. So since we had to do it this way and get a specific API call, we had to make that API call more than once. So in our case, we wanted to do a comparison. The only ones that we got to work was Vaughn's and Albertsons. So we did the Vaughn's eggs and Vaughn's milk. Compare that to the Albertsons eggs and Albertsons milk. Same product, but they just had different prices on the screens. So we added these price and milk prices together to get the Vaughn's total. We added the milk and egg prices together from Albertsons to get the Albertsons total, and we set that to the state. So then we try to retrieve. So in this screen, we're getting preferred stores list of which store the user wants to get the items from. In this case, since we only have Vaughn's and Albertsons, that's going to be already set to those areas. So when the Vaughn's and Albertsons shows up, we set the price data equal to the total price that we got from Vaughn's and the total prices we got from Albertsons. And then when you go to the preferred score screen, you should see the Vaughn's name and then there's the price associated with that total. As you can see in the demo that I showed. And this is other parts of the code which deals with that. Let's say the next sprint we're going to try to get the actual each item under the total price so we can see the individual items from each store as well. But now we can switch over to Team Gantt. In Team Gantt, as you can see, last sprint, or this sprint, pretty much working on web scraping. Need to change my hours. But really, I spent most of my time working on web scraping. And it took a while, still working on it. So actually, it says 1.75. I say I spent at least 12 hours. It needs to be updated. But in Sprint 8, I want to add a couple more items to the list. Me and Aaron's going to be working on the styling the preferred store screen to make sure the stores are being rendered correctly. I'm going to wrap up the price scraping and see if we can get other stores implemented in there. If not, then we just have to work what we have. And also fix the bugs to the preferred score screen, which me and Aaron's going to be working on as well. So it looks like I got a total of 19 hours next sprint. And that looks like we'll be wrapping things up after that. So thank you.